Okay, in this lesson, we're going to be talking about a geometric sequence versus arithmetic, which we just finished. Now, let's go ahead and define geometric sequence. A geometric sequence is a sequence in which the ratio between the consecutive terms is constant. So the ratio, anytime we see ratio, we're thinking division, multiplication. So if we take the second term divided by the first term, whatever you get there, that has to be a consistent ratio throughout the entire sequence. Now let's talk about that common ratio, what we mean by that. The common ratio is the numerical ratio between consecutive terms, what that actual ratio is. What am I multiplying by one term by to give me the next term? That's what we're asking ourselves. What do I multiply by one term to give me the next term? That is that ratio. The variable that we use is r. Now, since arithmetic sequences were linear sequences, is there a shortcut here? It's not going to be as useful, but I do want you to know that a geometric sequence is an exponential sequence, like a to the x power. So kind of like a logarithm type thing. So there is a relationship there as well. Now, examples here is determine whether the sequence is geometric. If yes, identify the common ratio and the next three terms. So from 6 to 12, I'm multiplying by 2, multiply by 2, multiply by 2. The common ratio would be 2. What am I multiplying by? So yes, this is geometric. The next three terms would be 96, 192, and 384. Number 2. From 810 to 270, notice it's shrinking. And a lot of people say that you're dividing by 3, divide by 3, divide by 3. Yes, that's fine, but what are we multiplying by? To divide by 3, division by 3 is the exact same thing as multiplication times 1/3. Multiplying something by a third, it will shrink it the same way dividing by 3 shrinks it. So the common ratio, yes, is 1/3, so it's geometric. So let's multiply by a third again, gives you 10. 10 thirds, and 10 ninths would be the next three terms in this sequence. Number 3, from -2 to 10, we multiplied by -5. Did we do it again? And then again here? Yes, we did. The common ratio here is a -5. Notice what happens when you multiply by a negative. It changes from negative to positive, back to negative, back to positive. It flip-flops back and forth. So this is, yes, geometric. The next three terms, if I were to multiply by -5 again, I'd get -1250, a positive 6250, and then a negative 31250. So there you go. Number 4. From 4 to 8, I multiplied by 2. Multiply by 2 again, and you do not get 20. No, this is not a geometric sequence. Number 5. From 4 to -1, I multiply by, I divide by a -4. Well, that's the same as multiplying by? Times a -1/4. Okay, so let's see, does that common ratio carry through the rest? Multiply this by -1/4, gives you a positive 1/4. Multiply that by -1/4, multiply tops and bottom, gives you a -1/16. Yes, the common ratio is -1/4, and it is geometric. So let's multiply by -1/4 again, gives me a positive 1/64. Multiply by -1/4 again, gives me a -1/256. Multiply by -1/4 again, gives me a positive 1/1024. Number 6, multiply by 2 gives you 4. Multiply by 2 again does not give you 16, so this is not geometric. Now what they did here, they squared and they squared that and then they squared that, but that is not a geometric sequence. Let's see, if you multiply -2 times 7 gives you -14, times 7 again gives you -98, times 7 again gives you -686, so therefore the common ratio is 7. Even though it's decreasing, but multiplying by 7, since it was already negative, is going to make it a bigger negative and a bigger negative. So yes, it is geometric. The next three terms we're going to find by multiplying by 7 again. -4802 be the fifth term there. The next one would be -33,000. 33,614. And the next term will be negative 235,298. Number 8. Okay, 3.2. We've got to figure out what we're multiplying 3.2 by to give me 8. And the way that we're going to find that, well, if you haven't noticed on the other ones, to figure out what we're multiplying by, you can take the second term and simply divide by the first. 8 divided by 4, which that one was not. But here, let's start with a simple one. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. So you can divide each term by the term in front of it. So we've got to do 8 divided by 3.2. Let me show you a trick. If you didn't have a calculator handy, multiply top and bottom by 10 gives you 80 over 32. Reduce that gives me, let's see, I can divide by 16 and I get 5 halves. That's it. That's what you're multiplying by. So if you were to multiply this by 5 halves, if you were to do 8 times 5 halves, do I get the next term? Cross cancel gives you a 4 and a 1. That's a 20. I do. Multiply that by 5 halves again, and you would get the next one. So my common ratio there would be 5 halves. So therefore, yes, it is geometric. Let's find the next term. So I've got to do 50 times 5 halves. Cross cancel gives you a 25 and a 1. That'd be a 125. Multiply 125 by 5 halves. Now that will not cross cancel, so you're going to get a decimal here. Or you could write it as 625 over 2. That's going to be 112. Whoops. 312.5. And multiply that by 5 halves again. Or again, this 5 halves as a decimal is 2.5. If you just want to multiply by 2.5 each time, that's fine as well. And your last term there would be 781.25. There you go. Next up, geometric sequence formula. The nth term of any geometric sequence can be found with the following formula. Each term in the sequence is equal to the first term times the common ratio. Now you've got to be careful here because to find the first term, you're not going to multiply by the common ratio at all. It's just there. However, to find the second term, you're going to multiply, let's write this down. To find the second term, you're going to multiply by the common ratio once. To find the third term, you're going to multiply that term by the common ratio again. So you're actually multiplying by the common ratio twice. To find the fourth term, you're going to multiply by the common ratio again. So you're multiplying by it 3 times. So this is where this comes from. You're going to find any term, a sub n, you're going to multiply by the common ratio n minus 1 times. To where a sub 1 is the first term. And again, r is the common ratio. So let's find our formulas here. Write a rule describing, then let's find a sub 6. So we're multiplying by 5 each time. So our common ratio is 5. Our first term is 1. So each term in the sequence is equal to 1 times 5 to the, now again, you've got to be careful because to find the first term, you're not going to multiply by 5 at all. So it's going to be to the n minus 1 power. To find the second term, you're going to take the 1 and you're going to multiply it by 5 once. To find the third term, you multiply by 5 twice. To find the third term or fourth term, you multiply by 5 3 times. So it's always to the n minus 1 power. Now that we have the formula down, honestly, the 1, since it is a 1, is pointless. You can just leave it as this. So we're asked to find the 6th term. So therefore, the 6th term is going to be 5 raised to the 5th power. And you can multiply that out if you would like. You would get 3,125. Now these things, since they are related to the exponential family, they grow fast. Just the 6th term is already up in the 3,000s. Number 10, we're decreasing here. We're dividing by 2, looks like, right? Which is the same thing as multiplying, which is what we need for a ratio. We're multiplying by 1/2. So therefore, our formula, any term in the sequence can be found by taking your first term and multiplying by your common ratio. n minus 1 times. That's your formula. So therefore, your sixth term, there's the formula. The sixth term, you're going to take 130 and you're going to multiply by 1/2 5 times. Because again, your first term is 130. To find your second term, you multiply by 1/2 once. To find your third term, multiply by 1/2 twice. To find the sixth term, you'd multiply by 1/2 5 times. When you type that into your calculator, or you can do 1/2 to the 5th power, that's going to be 1/32 to multiply that by 130, but you're going to get 4.0625. Notice that this is exponential decay. Remember decay we talked about, it's shrinking. Number 11. 2 times -4 times -4 times -4, common ratio is -4. So therefore, each term in the sequence is equal to the first term times -4 raised to the n minus 1, one less than whatever term you're looking for. So the sixth term would be 2 times -4 raised to the 5th power. Raise -4 to the 5th first, then multiply by 2, and you get -2048. Number 12. You're multiplying by 3, multiplying by 3, multiplying by 3, so the common ratio is 3. To find each term in the sequence, you take your first term and multiply by 3. One less than whatever term you're looking to. So a of 6 would be 8 times 3 to the 5th. You're going to multiply by 3 5 times. That makes sense. To find the sixth term. So that's going to equal 1,944. Number 13. We've got to figure out what in the world are we multiplying 135 by to give me 90, or 90 by to give me 60. So all you have to do is take your second term and divide it by the first term. And again, I like to just leave it as a fraction and to reduce it. I think 9 will go into both of those. That'll be a 10 and a 15. Reduced again, divided by 5 gives you a 2 and a 3. So our common ratio here is 2/3. And you could have done that by doing 40/60 as well. Divide top and bottom by 20 gives you a 2 and a 3. It has to be a consistent common ratio. So to find each term in the sequence, we'll take our first term and multiply it by our common ratio, which is 2/3 to the n minus 1 power. So the sixth term in our sequence would be 135 times 2/3 to the 5th power. And we can type that into our calculator, and we're going to get 17.7 repeating. Number 14. Looks like we're dividing by 4, or actually -4, which is the same thing as multiplying by -1/4. So here's your common ratio. So each term in the sequence will equal the first term times whatever your common ratio is to the n minus 1 power. So to find our sixth term, we're going to take our first term and multiply it by -1/4 5 times. And that's going to give you 3.125. Okay, our directions change on the next ones. It says use the information given to find the indicated value. So we're pretty much doing the same thing. We're given, on number 15, the first term. So our formula would be a sub n equals the first term times whatever the common ratio is to the n minus 1. So to find the eighth term, now I want you to understand that this notation is the same as this notation, a of 8. That's the reason I keep calling it a sub 8. Is equal to 7 times 4 to the 7th power would be the eighth term in the sequence, which is 114,688. Okay, number 16. Now this one's a little bit different. We're looking for the first term. We're given the fifth term is equal to -68. So our formula again, a sub n is equal to a sub 1 times r to the n minus 1. So let's plug in what we have, and it'll actually tell us what a sub 1 is. Our fifth term is -68. So a sub 5, let's plug that in. A sub 5, when n is 5, we get -68. So a sub 5 here is -68. A sub 1, I don't know. My common ratio they give me is -0.5, And since we're given ace of 5 here, then this would be 5 minus 1, which is 4. And I just have a little basic equation here. Negative 68 is equal to the first term times negative 1/2 to the fourth. We can raise that to the fourth power with our calculator. And you get 0.0625. Now all that's left is to divide by that, and that leaves us with ace of 1 is equal to negative 1,088. And if you'll look back, we could get a formula from that now, but that's actually what they ask you to find was ace of 1. So we're done. Now this one we'll have to go through all those. No, they give us our ace of 1. So we do have to find our common ratio though. So let's see if we can figure that out. My first term is 13. I don't know my second or third term, but I know my fourth term is 4,459. So see if this makes sense. We're going to have to multiply by our common ratio once, twice, 3 times. Since we're given a first term and a fourth term, that means we're going to take 13, we're going to multiply it by r 3 times, and it's going to give us 4,459. Well, guess what? That little simple equation can tell us what r is. Let's go ahead and divide by 13, and that gives me r to the third power is 343. When you get rid of the third power by taking the third root, that gives you r is 7. So there's my common ratio. If you take 13, multiply by 7 again, and by 7 again. Now you can go through the formula if you want to, but why not just say 13 times 7 is 91. 91 times 7 is 637. 637, you can check it, times 7 will give you that. So my A of 3 is 637. Number 18. We're going to have to do the exact same thing. We're given A of 2, and we're given A of 5. So let's draw me some blanks. A of 1, 2, 3, 4, and 5. I know A of 2 is 6, and A of 5 is 0.048. And I do not know my common ratio, but again, I know that if I multiply by my common ratio once, twice, 3 times, to go from one term to the next, you're multiplying by your common ratio. So I know if 6 times r to the third is equal to 0.048, divide by 6 gives me r to the third is 0.008. So therefore, r would be 0.2. There's your common ratio. And you can check that. Multiply 6 by 0.2 gives you 1.2. Multiply that by 0.2 gives me 0.24. Multiply that by 0.2 would give me 0.048. So my fourth term is there. If you did need to find your first term so that you could get a formula, there's another way of working that. My first term, to go backwards, I would have to, since I'm going this way by multiplying, to go backwards, I'd have to divide. I'd have to do 6 divided by 0.2, and that would give me 30. So my first term is 30. So if I did need a formula, ace of n would be my first term times my common ratio to the n minus 1 power. So there's another way of working it. To find ace of 4, we could simply plug in 4 there and do it the exact same way. Okay, we have an application problem. It says Jason bought a brand new car worth $38,000. The car depreciates its value by 20% each year. Now, if you go down 20%, if you lose 20%, deducting 20%, that means what it used to be worth, it is now worth 80% of original. So each year, if it's going down 20%, it is now worth 80%. So you've got to use that. So we started at 38,000. Here's my formula. Ace of n is equal to the original amount, $38,000. But each year it is now only worth 80% of what it was before. So you can do 80% once, 80% again, 80% again. There's your formula. It's now worth 80% after 1 year of what it was the first year. After the second year, it's 80% of that because it went down 20%. What would the car be worth in 8 years? So we're asked to find ace of 8. So that'd be 38,000 times 0.80 to the 7th power, and that would be about $7,969.18.